Welcome to today's webinar on the importance of whole food delivered antioxidants in the prevention of chronic disease. We are going to wait 2 to 3 more minutes as there's been a backlog here of folks trying to log into and get into this webinar. So I want to thank everyone for their patience, and we'll start in here in just 2 minutes. Welcome to a discussion on the importance of whole food delivered antioxidants as a primary method of disease prevention. My name's John Bagnulo. I appreciate your interest in this, and really hope that this is a very informative, applicable webinar that allows you to improve the health of your patients and those that you care for. This is a topic that I have spent a considerable amount of my career and my education involved in. I received a PhD in 2003, and my dissertation was on the role of blueberries in women's health, particularly. So it's something that's been near and dear to me for some time. I, with respect to disclosure, I serve as Functional Formularies Director of Nutrition. And, I just want to make sure that everybody knows that, complete transparency. I'm really involved in a lot of the research and development for that company. Why are antioxidants, why they are so pivotal, and what types of roles do they play in human health? These are 4 things that I want to make very clear today. The first is that they prevent oxidative changes to the various membranes of the organelles as well as an overall cell. And they also prevent oxidative damage or mutations to DNA. So that's one of the most important roles. The second is that these antioxidants that we're discussing, they have very significant anti-inflammatory capacities, or an ability to really mitigate inflammation through both direct antioxidant, anti-inflammatory mechanisms, as well as indirect pathways, meaning that they can actually turn specific genes on that will in turn reduce any person's level of inflammation or tendency to promote inflammation, as well as their influences on the microbiome. These epigenetic influences, in addition to having roles with respect to inflammation, can favor balance or homeostasis that tends to favor human health. And as you're going to really see here in a few minutes, the antioxidants can mitigate a number of different steps in the etiology or the pathology of heart disease, neurological disease, and in other areas of the body or organ system. So there's really layers upon layers here of how antioxidants promote and preserve human health. Now, as I think a refresher for all of us, and just kind of to give everybody more of an overview here on what drives chronic disease, there are 5 major pathways or biochemical relationships with respect to, and this is an area of nutritional biochemistry, how chronic disease is promoted or occurs, right? There's deficiencies with respect to sulfation and methylation. We know that, you know, a large number of people have issues with these that really cause, you know, changes in gene expression and can affect everything from circulation in the body, the immune response, you know. So those are two major biochemical pathways that, when there's an aberration, leads to chronic disease. Then, of course, there's inflammation, which everybody's familiar with, insulin resistance, which we obviously have an epidemic of here in the United States and a pandemic globally. And then what we're going to primarily talk about today, which is oxidation and oxidative stress, as the two are really one and the same. So if I used methylation as an example where we have to have a support system for the body in the area of methylation to do something as basic as keep our DNA tightly wound together and to favor proper gene expression and to suppress those genes or gene expression that could, you know, could really promote disease. You know, this is a real simple illustration from the National Cancer Institute that I like, and I always shared with my students in different courses I've taught. But, you know, you really want to keep as many of the histone tails less accessible to epigenetic influences, which could be environmental, right? They could be, you know, nutritional, obviously. And methylation is required for that, to keep that nice tight configuration. But when there's hypomethylation or inadequate nutrient or nutritional support for methylation, then, you know, that usually invites disease. And so this is, you know, this is a great example of where we know that around 12% of Americans, and it may be 12% of North Americans, from what some share, have these MTHFR genes, or methyl tetrahydrofolate reductase genes, where if they're homozygous, as you can see in this illustration, they have a really difficult time providing adequate methylation to do something like, you know, convert homocysteine to methionine, so that the homocysteine doesn't cause, you know, microvascular damage. We know that this plays a huge role not only in cardiovascular health, but obviously in neurological health and in other areas of the body. So that's just one example. You know, I think the question we really need to ask ourselves with respect to all five of those, again, inadequate sulfation, hypomethylation, insulin resistance, inflammation, and oxidation or oxidative stress, is that why is it that these five biochemical pathways now are so often altered or inadequately supported in humans? You know, we have pandemics with several chronic diseases. We know the root cause is in the area of nutrition, and in more specifically, nutrient deficiencies. Well, the best answer to that question is that, you know, over 60% of what people eat today, regardless of whether it's plant-based or animal-based, I mean, that's really, you know, I think less relevant than the fact that over 60% of it is highly processed, and it contains very little in the way of micronutrients. And this is extremely relevant to the topic of antioxidants, because you will only find antioxidants in whole, minimally processed foods. And so once a diet becomes 50, or in this case 63% refined, then you really start to appreciate the gravity of what we call hyponutrition, or a very low nutrient dense diet. And that's what most people now are eating. You know, if you take a look at all of the data, and, you know, NHANES data, I think, is great. That's the National Health and Nutrition Examination Survey that's given out at clinics and various health centers. And every 10 years, these numbers are compiled. And we're going to take a look, when we look at, you know, the role of antioxidants in neurological health, at one of the studies that was just published this month based on the last NHANES data. But NHANES data shows us really what people are eating, how much of certain nutrients they're getting, and it really gives us probably the greatest data set from which we can try to connect the dots, so to speak. And you know, the NHANES data that goes up to 2000 showed that, and it's always being analyzed, but it showed that carbohydrate intake was the macronutrient that had changed most significantly from the mid 1970s to 2000, and this has continued to rise. And so that's almost a tracer or a surrogate marker for changes in the average American diet. And we know that much of those carbohydrates have been in the way of refined carbohydrates. And again, you know, researchers have taken mice, which are genetically identical, and have given these mice diets that represent different sets of macronutrients, whether it's the carbohydrates, protein, and fat, or looking at qualitative aspects of those and the number of refined carbohydrates and levels of B vitamins that would be present in a diet of a different population. And what we know is that the mice on the right are the mice that get a more whole foods, more balanced, more nutrient dense diet that may represent what Americans may have eaten 50 or 60 years ago, as opposed to the mice on the left, which are consuming a much more contemporary or recent American diet, more calories from refined carbohydrates, less nutrient density. And again, this is all closely related to the presence of antioxidants in any population's diet. You know, other things that have been looked at are the amount of wheat that's been consumed since 1970. That has risen steadily. And what we know about wheat consumption is that it's almost always heavily refined. Whole wheat consumption has not changed very much from 1970, but the use of refined wheat products, refined wheat flours has jumped dramatically in the last 4 or 5 decades. And fortification, you know, something like niacin, which is added to processed and refined foods as a requirement that was established, you know, again, now over 60 years ago. But we know that as the amount of niacin rises in terms of how much the average person is consuming, it is reflective of how much fortified food or processed food are present in a population's diet. And that is something that has mirrored changes in our population's levels for certain, again, chronic diseases, diabetes, heart disease, cancer. Refined foods tend to mirror those incidence rates. Now, this isn't always the case, and I always think it's good to show, you know, a very different picture nutritionally when it comes to this, you know, this discussion around antioxidants and a nutrient-dense diet and a diet that's, you know, made up entirely of whole foods. You can still find areas in the world where populations, you know, eat a very traditional human diet, minimally processed, you know, whether it's plant-based, you know, again, I think that's important on some levels, but for this discussion today, it's probably less important than the fact that they're only eating whole foods. And these populations are like the New Guinea Highlanders, or in this case, the Catawans, who are also in the area of New Guinea, but just off the coast on the island of Catawba, where researchers from places like Harvard and other universities have spent a considerable amount of time examining this population and their lifestyle, what it is they eat, and why it is they seem to really miss the modern pattern of chronic disease. Catawans, you know, tend to weigh the same their entire adult life. You know, their waist to hip ratio never changes. Their blood lipids tend to stay very similar. There's a complete absence of hypertension. You know, systolic numbers actually go down with age. It's remarkable. And, you know, much of this has to do with the fact, the consensus is from all researchers and from all accounts, that this population misses the typical chronic disease pattern due to the fact that their diet exists entirely on whole foods. So again, just there's some phenomenal examples out there, and this is just one of them, And then we can look at the clinical evidence of what's possible. And the Frassetto paper is a great example of this. It's now 13 years old, which is hard to believe, but you know, when participants were put on a more Paleolithic diet, and again, that's not important. I really just want participants to understand that it's a whole foods diet. Everything's whole. When participants were on a whole food diet that was representative of a Paleolithic diet, again, made up of vegetables, large amounts of vegetables, nuts, seeds, you know, animal protein as well, and whole fruits, when they were put on that for 10 days, the results are nothing short of remarkable when you take a look at something like a fasting insulin baseline, you know, which is right around 10, and then that results in a change, a 68% reduction after 10 days in fasting insulin, which of course results in a homeostatic assessment, or a HOMA score, often referred to as a HOMA-IR score of 1.0, or a 72% reduction. And that, by the way, is probably the most accurate way to measure any individual's risk for diabetes or diabetes complications. It's this HOMA-IR score. And you can see the dramatic change in just 10 days with that type of dietary intervention. So again, what's possible, what's already existing in those human populations that do eat mostly whole foods or entirely whole food based diets is, I think, a real eye opener for a lot of us as clinicians, and it can offer us a lot of hope, I think, as a population and globally. So that was just a backdrop as to why chronic disease is so prevalent and how nutrition can play a role on a variety of fronts. And antioxidants are the primary mechanism by which the body resists oxidative stress or oxidation. Again, that's one of those 5 primary components of chronic disease. And I want to share with you today, I want to share with you 2 really clear, well-established models in the area of cardiology and neurology that demonstrate the role of antioxidants in, you know, not only preventing, but in mitigating the effects when there is some oxidative stress already present. So heart disease, we know, has two major components of oxidative stress, or where oxidation is going to drive that disease process. The first is on the cardiac tissue front, looking at cardiac muscle, looking at the smooth, vascular muscle wall of blood vessels. We know that there are, in a considerable number of cases of heart disease, there's damage there, and much of that damage is looked at initially as just being calcification. But what is it that drives that calcification? And it's ultimately oxidation, especially oxidation of the mitochondria, or the mitochondrial membrane, that is so critical to cardiac muscle and to cardiac health and to cardiac function. With the type of metabolic burden that is placed on the mitochondria within cardiac muscle, and keep in mind that muscle, heart muscle, right, it beats and it's working all the time. Very different than skeletal muscle, where we're talking about voluntary contractions and we have to recruit muscle when we want to use it. But the heart muscle is beating all the time, and because of that, and because of those very unique metabolic demands, the mitochondria within heart muscle is beating. It's beating all the time, and it has to generate a massive amount of energy, because that's what mitochondria really do for muscle and for all of our cells. And because it has such an incredible amount of energy being produced, with that comes in a large amount of free radicals, because free radicals are a natural byproduct of metabolism and of mitochondrial energy transformation, the Krebs cycle. So all of these free radicals that are being generated have to be neutralized. They have to be neutralized by the antioxidants that we produce in our body. They have to be neutralized by the antioxidants in our diet. And as well as that, they need to have at least more stability in the types of fats that these membranes are being comprised of. So it's a very, it's a very interesting dynamic in terms of what takes place in the mitochondria of our heart muscle. And what we know is that the omega-6 fatty acids, a polyunsaturated fat in the mitochondrial membrane, become oxidized, become damaged, and that drives some of the calcification of cardiac muscle, as well as it can help drive, the calcification of other tissues in the body as well. And so this is so relevant because these omega-6 fatty acids, they are oxidized at a much higher rate. Not only when they're occurring in a higher level in that cardiac tissue, but also when there is any type of change in the level of oxidation there due to coronary events, due to, different levels of stress, and anything that can, really influence what we call eicosanoid production. And so that's all ties into the inflammatory oxidative stress pathway. And really, the take home from this is that when we look at the free radicals being produced in heart muscle, in the mitochondria, and we understand that those free radicals are damaging the omega-6 fatty acids, as well as, to a lesser extent, the omega-3 fatty acids in heart muscle, the number one way to protect that is to, yes, minimize our consumption of omega-6 fatty acids and try to have a very favorable omega-6 to omega-3 ratio in our diet with the types of oils that we eat, but also to make sure that the mitochondria of our heart muscle, as well as the mitochondria, as we're going to look at in a moment, of our brain and our neurons, that those mitochondria are protected with the right mix and with adequate levels of antioxidants from the foods we eat. And the second front with which oxidation drives heart disease is how oxidative stress and oxidation, that process and the molecules that drive oxidation, how is it that they change our LDLs and what happens to our LDLs, or our low density lipoproteins? So just to remind everybody, LDLs need to be oxidized before they can infiltrate the intima of our artery lining. So for a blockage to occur in a coronary artery, which we know is probably the number one cause of an infarction or a heart attack, for that to take place, the LDLs, regardless of what level of LDL someone has in circulation, so it's not as much a function of a person's LDL levels or the number, it's more a function of the qualities of those LDLs. Are they small and dense? Because those are the LDLs that can be oxidized easily and will infiltrate the artery lining and eventually lead to what we call coronary plaque, outpocketing, and the blockage that generally results in a rupture and all of the clots that occur downstream from that. So in summary, large buoyant LDLs, which you see here in the middle of this slide, LDL, what we call pattern A, they contain more triglycerides and similar levels of cholesterol, but more triglycerides and a greater ability to hold and transport fat-soluble vitamins. That's incredibly relevant because fat-soluble vitamins and many fat-soluble antioxidants are how LDLs resist oxidation. So hopefully this is becoming crystal clear that LDLs drive heart disease when they're oxidized, and they're only oxidized when they are inadequately protected by antioxidants and fat-soluble vitamins. It's the LDL pattern B that you see on the far right, which is a smaller, denser LDL with less fat and more cholesterol in terms of the ratio, that cannot carry antioxidants, that is ultimately responsible for more coronary plaque and more heart attacks in the end than other types of LDL. And so, again, one of the great benefits of dietary antioxidants is their ability to, once incorporated into an LDL, offer that LDL a resistance to oxidation, and thereby less likelihood that they would be responsible for a blockage in a coronary artery or the development of calcification or coronary plaque. So two different mechanisms by which antioxidants protect heart muscle, blood vessels, and thereby reduce our risk for a coronary event or cardiac disease. Now, the other area of the body that I think all of us are increasingly interested in terms of helping patients and improving the health of those that we work with is neurological health and brain health, because it's really clear we have, again, an epidemic in the area of dementia, neurodegenerative disease, and Alzheimer's. And, you know, it's clear that there's definitely an environmental and a genetic component to this area of chronic disease. You know, Alzheimer's, you know, definitely being more and more characterized as chronic disease as opposed to purely a genetic occurrence. And, you know, despite the genetic and the environmental component, we know that nutrition plays a huge role in terms of any population's risk for neurodegenerative diseases and for dementia, as well as Alzheimer's. And that has to do with the unique effects of reactive oxygen species and oxidative stress on the inflammatory pathway in the brain. And what I mean by that is that reactive oxygen species, free radicals, will initially generate oxidative stress that ultimately light the fire that becomes the inflammation in the brain. There's been some great papers published on this in the last 3 or 4 years. This is one of my favorites, looking at the way that different phytochemicals offer protection against neurodegenerative disease, and how neuroinflammation is really the underlying mechanism here, and that this chronic systemic inflammation trickles into the brain, and that one of the most effective ways that we can, going forward, you know, address this and reduce any individual's risk for neurodegeneration and for dementia, Alzheimer's, is to really increase that individual's risk, starting at a younger age, of course, but at any age, their intake of both water-soluble and fat-soluble antioxidants. So that's one paper. And then just this month, within the last 2 weeks, in the journal Neurology, there was a great paper based on NHANES data, which we just talked about, you know, a few minutes ago, looking at NHANES data and the consumption of different antioxidants in relationship to the incidence of Alzheimer's disease now. So basically taking NHANES data from 2000 and 2010 and collecting that data, and then looking at what dietary antioxidant levels were like and a person's risk, as doing this as a follow-up study, looking at, you know, what was the likelihood of an individual developing Alzheimer's or dementia based on their consumption of antioxidants between the years 2000 and 2010. And it's really clear that there's a marked level of risk reduction when, especially certain carotenoids found in dark greens and some of the anthocyanins that are found in dark berries. It's really clear that those are highly protective vegetables and fruits with respect to both Alzheimer's and all-cause dementia in adults. So just a great paper. If you haven't had a chance to see that, we'll make sure that this is included in the reference list that you'll get. Now, you know, again, there's always at least one clear, sometimes two very clear mechanisms, and that's definitely the case with protecting neurons in the role of antioxidants in protecting us against neurodegenerative diseases and changes there. Reactive oxygen species, again, have the ability to damage mitochondria first and foremost, and then once the mitochondria are damaged, then any neuron loses the ability to kind of maintain or upkeep that particular cell or that neuron. So the mitochondria are responsible for producing all of the energy that any given cell is going to ultimately use for its own needs. And, you know, once mitochondria are damaged, then, you know, basically housekeeping falls apart within that cell. Then there's the second component to this, which is the ability for some of these reactive oxygen species to drive inflammation, and that inflammation we know causes things like microglial tangles and ultimately neuronal death. So there's just, there's that fundamental cause, reactive oxygen species starting to reach unhealthy levels for a particular component of a cell, in this case, let's say the mitochondria, or maybe reaching unhealthy levels for the entire cell and starting to damage other components of a cell as well. But ultimately that mitochondrial component and the levels of oxidation that it can withstand, that's usually the rate limiting factor when we start to look at cellular health and the relationship between antioxidants and free radicals or pro-oxidants. And from again, I shared a little bit with you initially about my PhD work looking at women's health, and I worked, I worked closely with Tufts University at that time, and there were some great studies going on there with animals, primarily under the direction of the late Dr. James Joseph, who worked at the Tufts University Center for Aging for years and was really one of the pioneers, in terms of looking at the roles of antioxidants and promoting neurological health, and all of his animal studies there that were done with things like spinach and blueberries and walnuts. Dr. Joseph just did so much groundbreaking research that helped us understand more about the roles of specific antioxidants and more importantly, foods in helping with a healthy aging process. Well, Dr. Joseph shared a variety of his animal slides with me at that time, again in the early 2000s, and a couple of the slides that I think I've always kept near and dear to me are the ones that he shared with me regarding changes in a neuron with different levels of antioxidants in the diet, and this would be for mice. And so here you see a highly branched, the branches are the dendrites of the neuron. You really want to keep those highly branched. It allows a neuron to establish more effective connections with other neurons. I think we can all understand that. And here's the neuron of a mouse at around 9 weeks old that has had blueberries in its diet at around 2 to 3% of its diet. That would be like, an adult having around 80 to 100 grams of blueberries a day, about a cup of blueberries. Here is of a genetically identical mouse, same age, without the blueberries in its diet. And you can see that the dendrites of the neuron are not very well branched. So you only have around 40% of the dendritic branching that you want. And so that's really, I think, just a really powerful image to show the difference in neurological development, neurological health with something as simple as blueberries being consumed daily. And if we take a look at the dendrites even more closely with an electron microscope, you can see that there's a lot of nodules there which will lend themselves to branching for these dendrites. And then again, with the mice that receive less or no blueberries, you don't have the same presence of those nodules. So there's so many different ways we can look at the role of antioxidants in both, again, cardiovascular health, neurological health, and we could go into other areas as well. But, a lot of nutritional epidemiologists over the years have said maybe we're a little limited in terms of what we categorize as a vitamin or mineral. We know that vitamins and minerals are generally categorized as such based on being essential for life. But, when you start looking at certain antioxidants, both the endogenous ones that we produce as well as some of the exogenous that we get from foods or families of antioxidants, wow, you can start to build a strong argument that they're essential for quality of life and protection against certain chronic diseases, at least if you categorize them as a class or a family as a whole. So with that being said, I want to take a look at now some foods and some molecules that serve as the best examples of antioxidants. And here's a chart. This is a USDA chart looking at the ORAC score. That stands for oxygen radical absorption capacity. So it really measures how much of a very potent free radical or a pro-oxidant, in this case cumene peroxide. Cumene peroxide is put in a test tube or in a container with a certain amount. It could be 1 gram, it could be 10 grams, it could be any amount of any given food, and then the concentration of cumene peroxide and how much of that cumene peroxide is neutralized by any given amount of a food is reflective of what we call its ORAC score or capacity. Basically it's describing how many of the free radicals in a test tube or in a container are neutralized by any given amount of a certain food. And so the higher the ORAC score, the greater the antioxidant capacity, at least in one particular area of antioxidant value. We'll take a look at this in a moment, but you can see here that certain nuts like pecans are actually very, very high. This is per 100 grams of fruit. That's a really important component to this chart. So you can see as you go to the right, you'll see that golden seedless raisins have a fairly high score, but 100 grams of raisins is obviously a lot of calories and a lot of sugar, whereas right next to it, you see blueberries. 100 grams of blueberries is going to be a fraction of the sugar and a fraction of the calories found in the raisins. So on a relative per weight, per fruit value, it's obviously a much, much higher score. Ginger should be noted. Ginger, again, 100 grams of ginger is a lot, but ginger has a very, very high score, as does, other spices such as turmeric, which aren't on here. These were just those selected here in this USDA chart to give us a nice linear relationship going from pecans down to the noni fruit, which is still a good score, but it's just not as high as you'll see for things like avocados and goji berries. And then, of course, blueberries are always a superstar, but it has a lot to do with the color, not specifically blueberries. If we had blackberries on here, they would be even a higher score. But the color blue and purple are almost always going to be very, very high ORAC scores. And this is from Ohio State University. You can see you have black currants, blueberries, black raspberries. They all have very high levels of these anthocyanins, which give them an incredible ability to donate electrons, which ultimately is how we neutralize, or how antioxidants neutralize free radicals. So again, black currants, blueberries, blackberries, marionberries, bilberries, all of those are going to be exceptional sources of antioxidants. But that doesn't, that doesn't, I think cast a shadow per se or a negative light on things like raspberries. They have decent antioxidant scores, but blue and purple usually tend to win when you look at a head-to-head antioxidant score. Now, again, just the basic understanding here of antioxidants for all of us is that they're multi-ringed in chemistry. They have these what we call benzene rings, okay? And that's just you can see here, you've got 6-sided rings with double bonds in them, and that gives them, I guess, an inability is the best way for me to describe it, an inability to hang on to those electrons that are part of the molecules attached to the ring. So a very weak binding capacity gives them an incredible ability to donate electrons when ultimately that's what we have to do to neutralize a free radical. We have to donate an electron to it to stabilize its outer orbital. It's probably more organic chemistry than a lot of us want to remember, but that's really what it comes down to. And so the greater the ability to donate electrons and the more of those electrons that can be given by any molecule, well, the greater the antioxidant value. And so here you can see what's found in green tea, right? A lot of us are familiar with epigallocatechin gallate. That's the one you see at the bottom right here, EGCG, and that's often how things like matcha and sencha green tea are looked at. It's on their their EGCG content because we know that's what gives green tea such a medicinal quality and such a high antioxidant value, and as well as some other attributes in terms of anti-inflammatory, anti-angiogenesis, all of those great properties that we associate with green tea. Well, here are the anthocyanins that are found in things like blueberries and blackberries, as well as in the skin of an eggplant. You can see that they're also multiple rings, so many side chains of that OH group that, again, it's just an easy thing for these molecules to give up electrons. And the cyanidin that you see in the upper left is what's often in the skin of blueberries and blackberries, and it's a really robust antioxidant. It's like 150 times more potent than something like vitamin C or vitamin E at any given quantity. So, and then of course we've got what's found in coffee. And what's interesting about coffee is it may be the greatest source of dietary antioxidants in the average American's diet. The average American doesn't eat berries every day. The average American doesn't drink green tea or use turmeric or curry every day, but the average American does drink coffee. And so, for that, coffee, and not all coffees are created equal, of course, but less filtered coffee, coffee that tends to have more fine particles in it, more of an oil component, so it's not run through a paper filter. That type of coffee tends to deliver the highest levels of these antioxidants, which are chlorogenic acid, cafestol, and of course caffeic acid. And these are very potent antioxidants that, going back to our discussion around LDL molecules and heart disease, these are great at protecting LDL molecules from oxidation. So it's a great reason to drink less filtered or unfiltered coffee. But these are all examples, all three of these groups, right? The molecules found in green tea, the molecules found in your dark blue and purple berries, and here what you find in the coffee bean or the coffee fruit. These are all great examples of some of the most potent antioxidants that are out there that we all have access to, and I think all of our patients should have access to, with a little bit of guidance from us in the right choice of foods. Now, how do we measure antioxidant activity? This is something, again, going back to my PhD work and some of the work that was done at places like Tufts University, University of Arkansas as well. Dr. Ron Pryor, who was formerly at Tufts, he's really the individual that developed the ORAC test. That measures, again, oxygen radical absorption capacity, whereas the FRAP test, FRAP, looks at the ability of any food to neutralize iron-based free radicals. We know that iron is a really potent pro-oxidant or free radical, meaning that iron can do a lot of damage to heart health in particular. And that's why, a lot of times people with high levels of iron are encouraged to give blood, so it'll offer them some protection against heart disease. It's why we know, hemochromatosis carries such a high risk for heart disease at an early age. So that FRAP test it's a great test. It's just not quite as popular as the ORAC test. And FRAP is interesting because it will measure a protein. If there's a protein in a food that has antioxidant value, it will measure that as well, whereas that doesn't get measured with an ORAC test. So there's different ways of looking at antioxidant capacity. I think it's good, whenever possible, if you're trying to assess a food's value on this level, looking at antioxidants, I think it's good to really include them both whenever it's possible. And everything ultimately is going to be compared to vitamin E, because that was for a long time considered one of the greatest antioxidants. This is early on when vitamin E was first, identified, and its role in human health was clarified. Everything really gets compared to that in terms of Trolox equivalents. So that's just some sidebars here in terms of how antioxidants are measured and what they're usually compared to. But we know that polyphenols, anthocyanins, and the carotenoid levels of any given food can be measured. And these are often great quantitative assessments that you can assume with higher polyphenols, there's a higher antioxidant value. And that's certainly the case with anthocyanins as a very specific polyphenol, as well as for carotenoids, which are, again, they're found in almost all vegetables, especially your brightly colored and your dark green vegetables. The interesting thing is that we know so much about antioxidant activity, but we have very little in the way of assessing anti-inflammatory capacities of foods. That usually is done with the use of ORAC, FRAP scores, and polyphenol content. So these things are always used as surrogate markers for whether or not a food would be potentially anti-inflammatory or not. And while we're on the topic of antioxidants, we're getting into some of the more important foods here I want to take a look at. I just want to remind everybody that vitamin D is one of the most effective antioxidants. And I say effective as opposed to potent, because vitamin D, it's a hormone, right? We make it internally in our body. We make it from cholesterol when we have adequate exposure to UV, ultraviolet light type B. So we can make vitamin D, we can ingest vitamin D, but it's a hormone. We have a receptor for it in every tissue in the human body, and we're pretty good at transporting it. And it's something that our LDL molecules are really good at transporting. And so higher levels of vitamin D, as you can see in this chart, and this is an older chart now, we're going back to the American Journal of Clinical Nutrition, 2007. I use this chart frequently, you know, when I was teaching at the university, to help students understand the protective role of vitamin D when you get beyond the current dietary recommendations, which are set to prevent rickets. When you start going in the other direction, you know, more towards a level of around 50, you can see that the incidence of so many diseases, chronic and otherwise, they're reduced, and that has a lot to do with the antioxidant role as well as an anti-proliferative role. You know, it has obviously multifactorial here when you get into something like vitamin D. It's an antioxidant, it's a hormone. It has a huge role in the immune response, but it's important to note that it is an antioxidant. And then when it comes to heart disease, you can see a significant reduction for men with heart attacks, you know, when vitamin D levels go from, at that time, 24 up to around 32, which is where we're at now. So vitamin D is a potent antioxidant, and it's one that the body's really good at using and transporting. Cranberries are one of the richest sources of polyphenols and antioxidants. I just love cranberries, not only because of that, but because they're so low in sugar. You know, this is a food that I think has such value for so many people that have, you know, various health conditions, chronic diseases. And I think it's a really preventative food for us to try to use more, whether that's in smoothies, you know, whether that's incorporating them into recipes, even if the recipes might be baked or cooked. There is some resistance to heat loss with cranberries. I mean, obviously, frozen and raw are going to carry the greatest antioxidant value, but this is a real superstar, and one that we should all try to find a new way to incorporate. Then there's almonds, especially the skin of the almond. You know, almonds are a great source of well-known things like vitamin E, but also a large number of polyphenols that are also, in addition to being fat soluble, these are, you know, nuts. We know pecans, almonds, the fats and oils in those are protecting our LDLs, like we've talked about, but a great source of fat soluble antioxidants, as is the case with avocados. I mean, I think avocados now are a food that almost everybody identifies with as being a healthy addition to a diet. What can we do to get this into a blender or get this into, you know, someone's meal, regardless of, you know, maybe what their chronic disease is? It's something that just carries so much value. And so those are two really unique because they're higher fat foods in the case of almonds and avocados. And turmeric, it's a fat soluble antioxidant, the curcumin that's in there. So it's important that turmeric be delivered to a patient with oil, with fat, and that it's cooked in some kind of oil or fat. But it is, you know, one of the most intensely studied and well-published foods in the, you know, peer-reviewed scientific database. Turmeric's #1 in terms of what's been shown in animal and human studies with its regular consumption. And a lot of that, again, has to do with its incredible antioxidant value. And as I've already mentioned, the one that I've spent most of my life researching and discussing is the blueberry, but I would not want that to, I would not want to really lose sight of the fact that blueberries in the blue and purple world are average, because again, blackberries, Marion berries, bilberries, you know, so many, the acai, of course, which people are familiar with. Every member of that blue and purple fruit world, even though they might not be related botanically, they're all very, very potent and the richest sources of antioxidants out there. So with that, I really, again, I appreciate your interest in this discussion today, and I look forward to trying to answer whatever questions you might have. Thanks so much.
Great, thank you so much. This is Laura, and I am going to facilitate some of the questions for Dr. Bagnulo. And we have quite a few, so we have about 10 minutes, and we will try and get through as many as we can. Okay, Dr. Bagnulo, here we go. So a very general question here, but as you went through the presentation, you talked a lot about whole foods. Can you actually provide a definition of whole food for some of the studies you referenced?
Yeah, sure. That is a great question. Whole foods are generally those which are minimally processed and have not had a significant or functional component removed. You know, an example of that would be fruit juice. Fruit juice is not a whole food. It's been processed. We've lost the skins of the fruit, which is very relevant to today's discussion because the skins contain 95% of the antioxidants and almost all of the fiber. So it's any food that has not had a significant or a functional component removed.
Okay, great, thank you. On the slide that talked about how you measure antioxidant activity, can you, what is the FRAP, the FRAP stand for?
Ferrous, which refers to a form of iron that can be a pro-oxidant. Ferrous reducing absorption potential.
Several questions here on coffee because I think, I mean, I know I certainly love coffee, so I think a lot of our listeners today do too. So a few questions on coffee. Why do I see studies that say unfiltered coffee raises LDLs?
Well, it does. In 5% of humans, the caffeic acid, which often gets filtered out with a paper filter, the caffeic acid can cause modest, not significant, but modest increases in total cholesterol as well as LDL. What is often not shared with folks is that despite the modest increase in the number of LDL particles or in the total cholesterol overall, that the caffeic acid, along with the other molecules that get filtered out, those are incorporated into the LDL and offer a significant level of, again, as I mentioned earlier, resistance to oxidation for those LDLs. So it does. You know, caffeic acid in about 5% of people. It's not across the board. I think it's less relevant, to be honest. I don't want to get bogged down in that number. It's it causes modest rises in cholesterol. Of course, LDL is going to go up usually when total cholesterol does. But the good news is the LDLs are typically more protected by the presence of those. And I do want to remind our listeners here today and any participant in future webinars that there are some excellent papers that have been published now which are really questioning any value whatsoever to assessing a person's risk for heart disease based on total cholesterol or LDL numbers. The British Medical Journal now has 3 papers. I can make those, Laura, I can make those papers available to anybody that's interested. But the British Medical Journals, looking at those individuals age 60 and over, showed that those with higher LDLs had lower all-cause mortality. So it's, you know, it's, again, we probably don't have time in today's discussion to go down that road, but I don't really look at how a food influences a person's total cholesterol or LDL as being, you know, really favorable or unfavorable. I really want to look at things on a more qualitative level. And I think unfiltered coffee really provides antioxidants that people would not otherwise get. But there is truth to that statement, though, that it does in you know, 5% of people cause mild increases in cholesterol and or LDL numbers.
Okay, great. Yeah, and I think we can definitely, if you send me those articles, I can include them on the reference list that we will send out after the webinar. So that'd be great.
Sure. You got it.
Is there a connection between coffee bitterness and amount of processing?
Not necessarily, because the more coffee is roasted, the darker it is. And this isn't, again, there are a lot of different factors. I'm not as much as I love coffee, I don't know if I'm, you know, an authority on coffee processing. I do know a fair about it from spending time in Panama and Costa Rica and living in those countries. But, you know, coffee is roasted for a variety of reasons, but one of those is to, you know, kind of control the level of bitterness. But so it's not as much a function of it being unfiltered as it is the processing of the coffee beans. You can take a very, and again, a medium to light roast coffee beans are the happy medium. This is where I think is most relevant to today's discussion. Medium to light roasted coffee beans are going to still contain high levels of these fat soluble antioxidants and be bioavailable and not be too bitter. Green coffee beans, which a lot of people like to do different things with, have not been heat processed enough to make some of those antioxidants bioavailable. Will have a little more bitterness. And, so it's one of those areas where the light to medium roast is probably what most of us are looking for if we want to get the most antioxidants out of our cup of unfiltered coffee. But I can't necessarily say that it's going to be everybody's everybody's preference with respect to bitterness. Some people like a really dark roasted coffee, like a French Vienna roast, but those are going to contain the lowest levels of antioxidants because they've been cooked or charred so much. So it's a lot of factors at work here, but the bitterness is not going to reflect filtered versus unfiltered.
Okay, perfect. Is there an age by which dendrite production can be impacted by diet? Meaning, after infancy, childhood, adolescence, can subjects increase the number of dendrites and number of branching channels?
There are animal studies. Yeah, that's a great question. I mean, certainly there's more plasticity at a younger age, but there is evidence, especially with animal studies, that plasticity does survive into our later years, even into elderly type years. It probably takes more of a concentration of some of the nutrients, or in this case antioxidants or molecules, to get there, and it may require the use of something like intermittent fasting, a ketogenic diet. I mean, this is, again, I don't have empirical evidence that any one of these things can provide a high level of dendritic branching later in life, but there are animal studies which shows that there is still some level of neuroplasticity and an ability to form more dendritic branching later in life. So it isn't something that's only accessible or only available to the human body at a younger age. It can occur at later years, but there may be kind of other factors that have to be woven in, like more of an adjunct type process.
Okay, that's great news. As I said over here, getting older every day, right?
Yeah, for
what
sure.
What are your thoughts on resveratrol supplements?
Yeah, so that, I think the question about supplements is one of the most interesting components of this that I didn't go into. I shared with you a lot of the work of James Joseph at Tufts University. And, one thing that Dr. Joseph, as well as Ron Pryor, who now, or last time I spoke with him was at Arkansas Children's Hospital, one thing they always, really imparted on me with my blueberry research in women was that, look, this is what we're going to show with animals, this is what we're going to show with humans, but whenever we give animals a antioxidant supplement, like they took the anthocyanins out of blueberries, out of the skins of blueberries, and they gave those to laboratory animals, expecting to see similar results that they saw with blueberry consumption. And in fact, the animals fared worse than those that got the placebo or the sugar pill. And that's, we've got a number of examples now. We've got the beta carotene studies, which have been done in Scandinavian countries, as well as here in the United States with people exposed to secondhand smoke and asbestos. We know that people who take beta carotene supplements are actually at a higher risk for lung cancer when they've been exposed to cigarette smoke or asbestos than those who got the placebo. And this, again, if this is news to anybody, or people are really, taken aback to hear this, there's an elaborate check and balance system that occurs in the human body with any type of nutrient that has the ability to influence gene expression. And the best way I can summarize this is that all of our cells, and I know this firsthand from my research and from researchers that I've talked, with about this, is that we have these genes that control things like apoptosis, right? A cell's ability to self-destruct. And in the case of beta carotene, if you eat a sweet potato or you eat a carrot, you don't get just beta carotene in that food. You get a couple hundred different carotenoids. Some of them might be at very low levels, but there's really a symphony of carotenoids in any whole foods. And what happens is with that, you get a very healthy check and balance type system where beta carotene isn't alone, and it's not going to drive all of the gene expression for an individual. Now, when it's taken alone, beta carotene can bind onto this P53 gene, which controls apoptosis, or the ability of any of our cells to self-destruct. We want our cells to be able to self-destruct. It's very important. It's a primary defense mechanism against cancer. And if we take beta carotene alone in large doses as a supplement, I'm not talking about eating carrots, I'm not talking about, eating any bright orange or yellow food. I'm talking about when we take it as a pill or as an isolated, highly refined antioxidant. It will bind onto that P53 gene and prevent a cell which needs to self-destruct. It will prevent it from self-destructing. And I think we can all understand the ramifications of that with respect to cancer. Now, again, all of the research done on eating more whole fruits and vegetables has shown that they are protective against chronic disease, against cancer, the incidence of cancer. So when you take any given antioxidant out of a food and you attempt to make it into a drug or a highly refined supplement, all bets are off. So my first-hand experience with animals receiving anthocyanin supplements made from blueberry skins, what I am familiar with in the way of beta carotene, what's been shown with other antioxidants, I think it really should give us pause and, really help us understand that we're making assumptions. It's all theoretical when we take any given nutrient out of a food and expect it to elicit the same type of response or favorable outcomes in humans. So, that's the best way I can answer that. I think resveratrol is a very interesting molecule. I think that whether you look at its ability to influence sirtuins, SIRT1, SIRT2, all of those sirtuins, which we know are important for brain health. We look at its role maybe in elevating AMPK, activated protein kinase. These things are, in my opinion, these are more theoretical than have been demonstrated adequately enough. I think that, if you look at where resveratrol is found, in the brightly colored berries are great sources of resveratrol. Certainly it's found on the skins of Concord grapes. I think those would be much more reliable and potentially helpful sources of resveratrol that I'd have a lot more confidence in than taking a resveratrol supplement. I know that was a very long-winded answer, but it's a complex question, so I thought I'd do it justice.
Sure, I think that was a great answer. I know we're a little over on time. Dr. Bagnulo, if you're okay, there's 2 questions. There are actually over 50 questions that we're not going to get to, but there are 2 questions that keep coming up time and time again. Do you have a few more minutes?
Yeah, absolutely.
Okay. The first question is, what about non-organic fruits and vegetables and the impact on the antioxidants in that situation, and or pesticide use on produce?
Yeah, I mean, that's a great question. And I think that, UC Davis, University of California, Davis, done a really interesting work here over the last couple decades on this. So we all know that, I shouldn't say we all know. I hope many participants understand that the majority of antioxidants found in any given plant are there to protect that plant against one of 3 things: insects, ultraviolet light, or some type of fungal, mold type pressure, environmental pressure. Those are the 3 main reasons why antioxidants occur in any given plant. It's protection against something in that plant's environment. And so what has been shown is that if you take one tomato, I go back to the Rutgers study of the 1980s, you take one tomato that's grown organically, and you take another that's grown conventionally, and you look at something like calcium, the calcium levels in a tomato plant, and this is also true probably with magnesium as well, the calcium, the magnesium, those type of nutrients are going to be very, very similar between an organic and a conventionally grown tomato or any other food. And so that is often what is shared with the public when someone makes a statement, there's no difference nutritionally between an organically grown tomato and a conventionally grown one. Well, that's really only half the story. The point of today's discussion is really around antioxidants and how important antioxidants are to human health. And so while fruits and vegetables do give us other nutrients, B vitamins, minerals, I'm in total agreement with that. I think that one of the most important things about fruits and vegetables in addition is the fermentable fiber found in vegetables especially, and the antioxidants. And whenever you spray a fruit or vegetable with a pesticide or a fungicide, or do something to offer it artificial protection against a pressure in its environment, then you automatically reduce the stimulus for that particular plant to produce an antioxidant that is there to protect it against that particular pressure. So that's why UC Davis has consistently shown higher levels of polyphenols and higher levels of antioxidant in plants which are grown organically. Integrative pest management, meaning minimally, the minimal use of pesticides or fungicides, compared to those which are grown conventionally with more regular, higher doses of pesticides and fungicides. So yes, to answer that question, there are differences in the antioxidant values of plants which are grown organically versus conventionally. But that being said, again, there are other factors as well, such as the amount of sunlight that a plant receives. That is important as well. That can have a huge influence, and really wouldn't be as much a factor between organic and conventional. But if you simply look at the use of pesticides or fungicides, those do in fact lower the polyphenol and the antioxidant content of most crops.
Okay, great. And I promised one more question. So decaf coffee and decaf tea, do they have the same antioxidant value as caffeinated versions?
No, they don't. It's unfortunate for people to hear this. I know we certainly have a significant number of people who are very sensitive to caffeine and really want to enjoy the taste or the flavor of those beverages without the caffeine. It's not to say they don't have any value. They still will have some antioxidant value, but much of it is lost because of the processing required to eliminate the caffeine. So they don't have the same value, unfortunately.
Thank you, Dr. Bagnulo, and thank you to everyone who attended. I know there were a lot of questions that did not get answered, and I apologize for that. It was a very popular question Q&A today. We do have another webinar coming up on June 8th, which Dr. Bagnulo is also our speaker for. That one will be on polyphenols and fructose, and you guys should receive an invite in a week or so about that, so look for that. I will send out continuing education credits within the next week to everyone that attended, and as well as a full list of all the references Dr. Bagnulo mentioned today. And the recording to this will be available on our website probably within the next 2 weeks. So again, thank you so much for everyone who attended and attentively listened. And thank you, Dr. Bagnulo, for all your time and knowledge.
Thanks so much, Laura. I really appreciate it.
You're welcome. Talk to you soon.